Welcome to Sciencera. In this video, we're going to discuss inflammation. The overall reaction of body to injury or invasion by an infectious agent is called inflammation. Both cellular or humoral mechanisms are involving in this complex. Tissue damage causes release of vasoactive and chemotactic factors that trigger a local increase in blood flow and capillary permeability. Permeable capillaries flow the influx of fluids and cell. Phagocytes migrate to the site of inflammation. Phagocytes and antibacterial exudate destroy pathogens. Five cardinal signs of inflammation are redness, calor, tumor, dolor, and function lysa, which mean loss of function, pain, swelling, heat, and inflammatory response. Seven steps involving inflammatory response are: number one, bacteria and other pathogen enters the wound. Number two, platelet from the blood release blood clotting proteins at the wound site. Mast cells secrete factor that mediates vasodilation and vascular constriction. Delivery of blood, plasma, and cells to the injured area increase. Neutrophils secretes factor that kill and degrade pathogens. Neutrophils and macrophages remove pathogen by phagocytosis. Macrophages secrete hormones called cytokines that attract immune system cells to the site and active cells involved in the tissue repair. Lastly, inflammatory response continues until the foreign material is eliminated and wound is repaired. Acute inflammation. Alteration in vascular caliber that leads to an increase in blood flow, structural changes in microvasculature that permit plasma proteins and leukocyte to leave the circulation. Immigration of leukocyte from the microcirculation, their accumulation in the focus of injury and their activation to eliminate the offending agent are the three steps involved in acute inflammation. Neutralizing pathogens. The increase in blood flow and capillary dilation bring into the area more antimicrobial factor and leukocytes that destroy the pathogen. Dead host cells also release antimicrobial factors. Blood leakage into tissue space increases the temperature and further stimulates the inflammatory response and may inhibit microbial growth. A fibrin clot often forms and may limit the spread of invader so that they remain localized. Phagocytes collect in inflamed area and phagocytose the pathogen. In addition, chemicals stimulate the bone marrow to release neutrophils and increase the rate of granulocyte production. Acute phase reactant. They are produced primarily by hepatocytes within 12 to 24 hours in response an increase in certain intracellular signaling polypeptides called cytokines. C-creative proteins occur in 6 to 10 hours in 0.5 milligrams, result in 500 milligram per DI, non-specific. Serum amyloids A occurs in 24 hours in 3.0 milligram. Interferons, originally named because they literally interfere with viral replication process in an infected cell, play a role in immunoregulation, produced during innate response. Type 1 IFN or non-immune IFN interferons, produced primarily during initial innate response to the viral infection. IFN alpha produced by mononuclear phagocytes. IFN beta produced by fibroblasts. Type 2 IFN, also known as immune IFN or interferon, because it is primarily produced as a component of the specific immune response to viral and other pathogens. Also known as gamma interferon, produced by T cells, RTH1. Tumor necrosis factor. Major mediator of an innate defense against gram-negative bacteria, induces secretion of APR. TNF can also directly trigger apoptotic death of some tumor cells through receptor-mediated mechanism. Pro-inflammatory agents include IL-1, IL-6, and IL-8. IL stand for interleukins. Two types of tumor necrosis factors are cactin produced by macrophages and lymphotoxins produced by CD4 plus and CD8 plus cells. CD4 are the T helper cells and CD8 are the cytotoxic cells. Chronic inflammation versus acute inflammation. Acute is good inflammation and chronic is bad inflammation. Acute, a serious threat trigger inflammation such as cut, bruise, or infection. The body release inflammatory compounds. The job gets done and anti-inflammatory compounds are released. The body goes back to business as usual. In chronic or bad inflammation, a non-serious events trigger inflammation like eating a certain food, acne, bacteria. The body releases inflammatory compounds. The body does not release anti-inflammatory compounds and keeps sending an inflammatory response. This brings us to the end of inflammation. I hope you understand today's topic. If you like my video, don't forget to subscribe for more.